So guys, right up here when we look back at that previous, I'm going to go back to this previous slide right here. It said, talk about your slopes right here. I'm going to move these back over here again where they were. Hopefully it'll let me get that green dot out there again. I don't know if it will. Maybe not. Well, anyway, we talked about this as this purple line was dragging. We would have had a horizontal line right here at +3 and at -1. And that's what it's telling me right here, guys. When I get to -1, the slope is 0. So everything over here, the slope was positive, and they're plotting the correlating slopes at certain points with it. Now, right here, you said the slope was 0, right? From -1 to +3, the slope becomes what kind of a slope then, kids? Negative. So as I move the slider to the right, slope's negative, 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 and it's starting to wrap back up. Why is it starting to wrap back up here? Your slope's negative, 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 but it starts turning back towards a slope of what here, kids? 0. So it's got to start coming back up to 0, doesn't it? And when I get to this b value of 3, my slope should be what again? Okay, right here, slope is 0. So does it make sense that 3, 0 is plotted for the derivative or to these slopes at certain points? Now as I go from 3 and beyond, what's going to happen to your slope? It's going to start moving up more and more and more, okay? And my friends right there, those points right there are kind of saying, okay, I can know the slope value at that point. So for instance, right here, this point down here in red is 3, -2.5, right? That point on f of x is 3, -2.5. But this tells me the point that's up here, 3, 0, this says at x3 the slope is 0. There would be a horizontal tangent line down here that would tell you that slope. Okay? So guys, what we're going to start getting into in this section when we start the notes with this, we're going to say, all right, here's a graph. I want you to sketch the derivative. Do you see all those purple points right there? A sketch of the derivative for that particular red graph, or f of x, would be the connection of those purple dots right there, okay? So at each point, we're kind of identifying what the slope is. So let's move on to the next slide and see what happens here. So it says, what is happening to the red graph of f of x when the purple derivative goes to 0? Well, when we get to here and we get to here, it says what's happening. So when we get to those slopes of 0, we're either at a maximum point or a minimum point, okay? Do you guys agree? How does the derivative change when f of x is increasing versus decreasing? Well, if the graph is increasing right here, like it was from here, are my derivative values positive or negative? Are they above the x-axis or below it? Above. Okay, now when I go from this point right here to where it's decreasing, this is where a 0 was and this is where a 0 was. Why is this part of the graph right here in purple below the x-axis? Because that's the part of the graph where your slopes were negative. So we denote those slope values as values below the x-axis. Then, when I get right here, guys, my positive starts doing what? Or my slope starts doing what? Going positive. So this is going to start being more positive, more positive, more positive. We're graphing those slope values. So it says, how does the derivative change? Let's answer the first question. What is happening in the red graph of f of x when the purple derivative graph is 0? Okay. The red graph is at a peak or a valley when the derivative is 0. Okay. Then the second part of this question, it says, how does the derivative change when f of x is increasing versus decreasing? If f of x is increasing, if f of x is increasing, where are the purple dots at? Above or below the x-axis? Then f prime of x would be positive, right? So I'm going to write this f prime of x is positive. Okay, so what's that mean if f of x is negative, kids? If the red graph is decreasing, what's that say about f prime of x then, kids? Again, keep in mind, f prime of x is just a fancy way of saying what's true about the slope. If I say a graph is increasing, you say the slope is positive. If I say a graph is decreasing, you say the slope is negative. So in this context right here, if f of x is decreasing, then f prime of x would be negative. Very good. Give me a show of hands right now, but are you on board with me right now? Who's on board with me right now so far in terms of what's typed up here? Okay, we're just talking about increasing, decreasing. If a graph's increasing, first derivative is positive. If it's decreasing, first derivative is negative. And if we get to a peak or a valley, then what's the derivative? What value? 0. Okay. All right. Guys good on that slide? All right, let's move. Let's try this again with a different kind of function. It says, where is the slope of the tangent line 0? So where on this graph would you have horizontal lines of tangency? Where do you think that would be, kids? In other words, where is the slope 0? We said the slope would be 0 at a peak or a what? Are there any peaks and valleys to this? Okay. Tell me when to stop the first slider. About -1 here? Oops. Okay, so if I come down here to my point, you think -1, 2.5, if I drew a line of tangency right here, it'd be a horizontal line? Okay, where's the other one going to be? +1. Okay, so we think right about there, we'll have a, so about that point right there. Okay. On the left, is the graph decreasing or increasing? Would you have positive slopes or negative slopes here? Okay, until we get to 0. And then the slopes go big time positive back to what? And then negative until they get really close to what again? Okay, so let's do this. It says, where is the slope of the tangent line 0? I think we drug the blue dots to the x values that we think that were there, so we've covered that. Next question, when do you think the derivative will be positive? Okay, we think the derivative, which is f prime of x, should be positive or greater than 0 for, where do you think that's between then, kids? What values do you think f prime of x will be positive, or the slope is positive? Okay, so can I write it this way for -1 less than x less than 1? Is that okay? All right. When do you think it'll be negative? So we think f prime of x will be, oops, not double prime yet. We'll get to double prime stuff. F prime of x will be negative or less than 0 for, okay, where is it going to be less than 0? Where do you have negative slopes, kids? So less than -1. So left of -1, right? And where else? Greater than 1, or right of 1, right? Okay. And then it says, what do you think the end behavior of the derivative will look like? Guys, the slopes are both negative right here. So I would say, looks like this is just going to continue to be, looks like there's an asymptote here for the top half and the bottom half. Guys, that slope eventually is probably going to flatten out really close to what? So this slope, kind of negative here, as I continue to move my slope along this line, it's starting to flatten out almost to be a horizontal line, right? So the end behavior slope, about what value are you thinking? Horizontal slopes, which would be what value? 0. Okay, so we think the end behavior for this, I'm going to write down end behavior slopes approach what value? Approach 0, right? Okay, so let's go to slide 5 and see if this is true. Okay. It says, how are your predictions? What did you confirm? I don't know. What am I supposed to do here? Okay, in between -1 and +1, do we have some pretty high positive slopes here, kids? I think we're good, aren't we? I thought there was something I could click on this. Maybe not. Let's go to the next one. I don't like that one. Let me... Did I go one too many? Ah, here we go. This is what I want. Thanks, guys. So verify my prediction. If I let B start here, continue to move, do I have positive slopes? Does it look like our slopes were 0 at -1 and 0 at +1? And then our slopes went negative but started flattening back towards what value again, kids? Okay, does it look like it's flattening back out to a 0 slope? Think we're pretty well right on that? Okay. So let's go to 6. How are your predictions? What did you confirm? What were you surprised by? We were what? Weren't we correct on that? Okay. So I'm just going to submit that gnarly. Okay. We were correct. Cool. All right. Next. Number 7 then. Any questions so far, guys? Okay. Next one. Predict where the slope of the tangent line is 0. Okay, so where is the slope 0 at in this one, kids? Drag, where at again? So we think -4, I'm hearing? Okay. -2. So that's where I've got kind of a peak up there, is that right? Okay. All right, let's talk a little bit about this. Guys, I agree that this is a peak. We've seen curved stuff like this. But what's different about these valleys compared to any graph that you've seen so far? They come to a point that's more, it's like a sharp corner instead of a curve, right? Okay, let's just see what happens. We think maybe there's some 0 slopes going on here. Okay, let's move on and see. It says drag the slider for B to generate the points of the graph of f prime of x. So B is at -6. Guys, if I'm at -6, do I have positive or negative slope? Okay, so this is going to start with negative dots down here as I move to the right. So here we go. Do we have negative slope so far? Negative values down here to indicate negative slope. All of a sudden, let's get to this -4 value and let's take a peek at what happens. Guys, at -4, at x equal -4, did it even give us a slope value at -4? Okay, here's the deal. On a curve right there, I can get a line to hit one point, but at a point right here, if I had a triangle right here, couldn't you, like, it's kind of like a, oh, what do you guys call it when you were little kids? The seesaw, or some kids call it the teeter-totter. Anybody ever call it the teeter-totter when you were little? I love it. Guys, I could put a ruler up there, something flat, at that one point. You could have a line going this way. That teeter-totter could be any different way, but it still pivoted at the same point, didn't it? So it's possible to have multiple tangent lines at sharp points. So when we have multiple tangent lines at sharp points like this, we say there is no slope there. Therefore, the derivative at this point does not exist. So if I keep going, what's true about the slope right here, kids? Positive until it gets what? To 0, and then it goes what? So this is going to kind of come through down to here. So as I continue to move, these are positive slopes for the red graph until I get right there. Then the slope is 0. And then continue to move right. Am I going to have a point underneath this sharp point? So when I get to x equals 0, did it plot anything on that x equals 0 line, kids? Didn't, did it? Okay, so what's true about the slopes at these sharp points, kids? They don't exist. We don't know what it is because it could be multiple tangent lines there. And then what happens to my slope here then, kids? Goes positive everywhere again, doesn't it? So the key idea here when you see a graph like this, that's what you would have as a graph. Key idea being right here in slide number 9. What makes the derivative's behavior at x equal -2 so different than that at x equals -4 or x equals 0? I'm going to say at x equal -2, right up here, kids, we can get a slope, which is 0, We can say that at that peak we can get a slope because that line is not, or I should say that point is on a curve and not at a corner. So at x equal -2, comma, that point is on a curve, whereas at x equal -4, yeah.
Could you send Michael Niebergall to the office?
Yep. Michael, what'd you do now? I don't know. Just show him your Hawkeye sweatshirt and life will be good, okay? Okay, x equals -4, and at x equals 0, we don't have a curve, we have what? Sharp corners, right? And then the thing you're learning today is that if I have a sharp corner anywhere in the graph, is a slope going to exist there? No. Okay? Guys cool with that? Okay, so now you've explored some functions and their derivatives. You're ready to identify graphs of derivatives. On the next page, we're going to match graphs of derivatives with the graphs of their functions. So help me out with this, okay? It says match each red function with its what? Green derivative. Should we start with, oh boy. Okay, this is the hard part, right? Do you guys have one? Do you have that slide?
Yeah.
Okay, let's take this red one right here. Guys, what's true about the slope everywhere in this red graph? It's negative everywhere. Is it the same negative slope everywhere? So if the slope was like -2 up here, and -2 here, and -2 here, and -2 here, the slope everywhere would be -2, right? So if I was graphing a derivative, wouldn't it be this one right here to say, oh, everywhere the derivative is the same negative value? So wouldn't these two match right here? So let's put that one with that one. Okay, those are the two cards I want to move over here. All right, let's pick on one. Red ones are the functions, right? I'm going to pull this red function up here. My friends, this red one, I don't want to match that. This red one, my friend, is the function. What's the slope here everywhere? 0. So wouldn't this have to be the one right here that's the derivative, saying, oh, this is the green one. Everywhere the derivative is what value? Okay, so, oh, shog ditty ditty, the cat and the kitty. I want to drag that here. Okay. So I've got those set. Okay. Guys, let's talk about this jagged one right here. I'm going to make some room here. The one with the what? Do I have one? Oh, I think I put that one down here accidentally, didn't I? I don't want that in there. So you're matching this one with this one, Connor? Okay, so everywhere the slope was the same negative value, but at the sharp corner, aren't we going to get a gap here? And then my slope suddenly turned to positive. It was a sharp corner. You guys understand why this is the match here? Okay, so I'm going to move those together. All right, let's talk, kids. The red ones are the... Okay, let's talk about this one. Moving from left to right. Slope positive or negative? Negative until the slope gets to what? And then turns to what? Okay, so which of these green ones does this have to match? Starts out negative, gets to 0, and then goes to positive. Would this be the right one? Or could it be this one? How many think it's this one? How many think it's this one? So we think this one? Okay, slopes are negative, negative. They come to 0. So negative, negative, negative to 0, all to positive. This one here would say slopes are negative, gets to positive, but then the slopes go back to what again? Is that happening here? So we think that's a match. Michael, life good?
What?
Life good?
Yeah, that's not bad.
Slopes all here or what? Slopes here are all positive. They get to 0, so positive slopes. I know the line here has got a negative slope, but we want the values. Positive values for slope, And then right here we get to a 0, and then they go negative. So doesn't this one have to match this one? Which means what here? Okay, so this one right here, slope's negative to start, right? Then it gets to 0, goes positive from here to here, back to 0, and then negative. So this has to match. These two have to match. Okay? So let's see where we're at next. Help me sketch this, kids. Where are my 0 slopes going to be? -2. I'm going to plot -2 there. Where else? Okay, so start for my derivative. Are the slopes negative or positive to start, kids? You guys agree negative? Okay, so I got to start at the bottom somewhere. These are negative values until my slope gets to what here? Okay, and then from here to here, what happens to my slopes? Oh, this is really bad. Oh, hang on, I messed there. I can't draw this very well, guys.
I can't draw with the mouse.
Can you guys, are your Chromebooks touchscreen?
No.
Okay. You guys get the idea here, right? So positive or negative slope, and then from here to here it goes negative or positive, and then at this point right here, slopes start going negative, okay? Okay, so positive through here. I did too. I think I did too.
Yeah, try it in a different color. Yeah, that should help.
That should help, you think?
No. I think it's gonna make it look even worse. Even bigger.
Okay. You get the idea. Let's go to 14. All right, where are my zeros going to be at here? About -4 in here. Where else? There, and you guys agree with that? Slopes start out how, kids? So I got to start up here somewhere to hit this point, and then they go negative slope to here, right? Until I get back to what slope?
Yeah, you can draw a straight line, Jay.
Yeah. Then they go to positive, don't they? Back to what slope again? Slope of 0 here, right? And then they go negative down here. So there's a good sketch of my derivative of that. Okay? Ooh! Help me with this one. What's the slope at the very beginning here? Everywhere here it is what? Okay, but it's horizontal here though. So isn't that slope going to be 0? It's neither increasing nor decreasing, right? So from here to here it's going to be... Why didn't that connect? Okay, okay with that? Now, all of a sudden here the slope is what kind of slope? So we're going to have a jump in this, right? So it's going to kind of go to here. And then at right here, isn't this where your slope is 0? And then it goes positive all the way up to here. But my friends, then what kind of slope do we have here? Negative. And that negative is, what is that negative slope here? How far down and how far over do we go? Like from here, how far down and over what? So starting at this point, the slope is what value? Isn't it -2? Okay, do we understand why there's breaks in this graph for the derivative? The reason there's breaks in the graph for the derivative there is there's sharp points there again. Okay? Sharp points. All right, friends. Let's see what the end has here. Let's see if we got it right. Did we have kind of that U shape? Okay, so we were good on that one. We had a function that looked like this, and we had, what did ours look like? You remember? Kind of like that? Let's check. for g prime of x. Do we have kind of the same thing? Okay, and let's check for h of x.
Quick announcements before win time today. The ISTEP meeting for this morning has been
Do
canceled.
we have something like that?
ISTEP has been canceled, so students in that, please report
Okay.
to WIN study hall today. Also, there will be a very, very, very short cross-country meeting in Mr. Parsons' room at the beginning of WIN. So if you're a cross-country team member, please stop in Mr. Parsons' room at the beginning of WIN. Also, Corbin Clark, please stop at the office when the bell rings.